Heat treatment simulation by TherMet solutions. An integrated approach to the quench heat treatment of steel components, forgings, castings, and machine components from the preheating stage to the tempering stage. The heat treatment module of the TMMFE software, Thermomechanical Metallurgical Finite Elements, and engineers a solution to heat treatment simulation. TMMFE HT uses the JIT pre and post processor for generating mesh, specifying heating and quenching conditions, material data, and viewing the results of simulation. Solid model of the component may be imported from other software like SolidWorks, STEP, etc. It can also be generated within JIT. Preheating conditions, furnace temperature profile during soaking, and cooling conditions during quenching, heat flux, are input using the wireframe model of the component. The software has unique features whereby the user can input the exact quenching conditions of the component. The heat flux is measured in the plant for accurate simulation and input in the form of a mathematical equation. TherMet Solutions has developed a new tool, a reference quench probe, for measuring heat flux in the plant. A typical heat flux model is shown here, derived from plant data. Refer technical manual for details on how to obtain a regression model based on plant measurements. An advanced model of heat flux during quenching can also be developed for more accurate results. Advanced models for heat flux during quenching have been developed when the surface temperature varies largely just before quenching. These models are developed by measuring heat flux when specimens are quenched from different initial temperatures. The steel grade is selected from the database of steels, which is a part of the software. Simultaneously with the selection of steel grade, its composition, critical temperature, and TTT diagram are loaded. Other properties are also input at this time. Reduction in elastic modulus with temperature is modeled from published results. A typical reduction ratio in the Young's modulus of steels with temperature, giving its ratio at room temperature to that at elevated temperature, is modeled from the literature data. User may input their own model parameters. Similarly, reduction in yield strength with temperature is also modeled as a ratio at room temperature to that at elevated temperature. User may again input their own model parameters. Thermophysical properties, density, specific heat, thermal conductivity as functions of temperature and phases are common to all steels and loaded at the time of assignment of steel grade. The software takes into account the latent heat liberation during transformation of austenite into its product phases. The last step in pre-processing is the process data input. This set of data gives the user a feel for the effect of process variables like soaking temperature, etc. on the hardness, phase distribution, and stress distribution at the end of quenching. A view of the solid after meshing and pre-processing. The pre-processed data is written in a specific format and submitted to the solver. The solver is indigenously developed, which keeps track of the austenite decomposition into its product phases as the component is quenched. Extensive lab trials have shown that the computed hardness at the end of the quenching period is within plus or minus 2 RC. The stress distribution is also computed. All the simulation results are then exported back to the JIT post-processor. A typical display of hardness distribution, Martensite distribution, binite distribution, retained austenite, the stress distribution, and the temperature distribution along with cooling curves at any point. Extensive lab and industrial trials using 10 steel grades and 6 quenchants have shown that the hardness prediction is within ±2 HRC. For further inquiries, contact TherMet Solutions Private Limited, Bangalore, India. Thanks for watching.